So for chapter 6, module 4 exam, question 1 asks us to show the relations between a hexagon, trapezoid, triangle, and rhombus. It wants me to show using one shape, use the other three, and show how much they either take up or how much they are missing. So in this case, we will have fractions. And as you can see, I gave a quick example of the steps that I took to find my answers. So the first one, I used a hexagon. So now I have to show the relations between the hexagon and trapezoid, hexagon and triangle, hexagon and a rhombus. The first one is the trapezoid. As you can see, if I put one trapezoid inside of a hexagon, it only takes up half of the space. So one trapezoid will fit into a hexagon twice. So that means 1/2. A trapezoid is 1/2 of a hexagon. Now, if I were to put one triangle inside of a hexagon, it would be able to fit inside the hexagon 6 times. So there's 6 possible spaces, but we only have one triangle. So that will leave us with 1/6. 1/6 is the triangle because only one triangle will fit. 6 triangles will fit inside of a hexagon, and we only have one. Now, with the rhombus, as you can see, I drew out the pattern for the rhombus, and it's still right here over with number 1. One rhombus will fit into a hexagon 3 times. As you can see, I showed you 3 different rhombuses, and we only have one that we're dealing with. So, since it'll fit in it 3 times, we only have one. Our answer is 1/3. Now, let's come down here to the trapezoid. And with the trapezoid, I'll be demonstrating it fitting with a triangle, rhombus, and a hexagon. Now, as you can see right here, the trapezoid and the triangle will fit inside a trapezoid 3 times. And since we only have one triangle, our fraction is 1/3. Now, we're going to come over here with a rhombus. We're going to place a rhombus inside of a trapezoid. And as you can see, it's kind of odd. Only one rhombus will fit inside of a trapezoid. And you can't get 2 full ones. So it's kind of like an odd fraction. And if you put a rhombus in half, it would be 2 triangles. And then there's one triangle left over. So that's why our answer for this one is 2/3, as you can see right here. Now, if you come over here, you can see the trapezoid into a hexagon. You can't even fit one full hexagon into a trapezoid. So it would take 2 trapezoids to fit one hexagon. So we have 2 trapezoids over 1 because we only have one hexagon. We need 2 trapezoids to fill it up, and we're dealing with the trapezoid. Now on to the second half of question 1. We have the triangle up here at the top. We're going to put the triangle in with the hexagon. Now with one hexagon, it will take 6 triangles to fill it up. So we have 6/1 because we need 6 triangles, and we're dealing with triangles. Now over here with the trapezoid, as you can see, I drew it out again. We will need 3 triangles to fill up one trapezoid. So our answer is 3/1 because we need 3 triangles to fit into one trapezoid. And now with the rhombus, it'll take 2 triangles to fill up one rhombus. So since it'll take 2 triangles, one triangle will fit into a rhombus twice. So we have the fraction 1/2 because a triangle is half of a rhombus. Now, down here for the last part, part D. Rhombus can fit into a hexagon 3 times, and would only have one hexagon, but we need 3 rhombuses. So our fraction for this one will be 3/1. One rhombus will fit 3 times into the hexagon. Now come over here to the trapezoid. Only one rhombus will fit into a trapezoid once, with half of the rhombus left over. So we will have 3/2. Essentially, as you'll notice, these fractions are kind of flipped as seen in the other examples. As in, if we were to go back to the trapezoid and the rhombus right here, it's 2/3. Then we come over here to the other side, it's 3/2. Now, dealing with the rhombuses, triangle, we have one rhombus can fit into two triangles. So again, it is 1/2. And up here, as you can see right here, I did this wrong. It should be 2/1 because the triangle is smaller than the rhombus. So yes, it should be 2/1. Now I skipped number 2. I didn't know how to do number 2, so I wasn't going to mess too much with that because it was at the very end. So we're going to skip over to number 3. And number 3 wasn't bad at all. It's simply just adding and subtracting fractions. So we will add 4 different sets of fractions. I'll give you examples, show you how to cross multiply the butterfly method. To use this, we will have to get the denominators the same. We will multiply the denominator together, then that'll give us our denominator in our answer. Then after that, we'll cross multiply, as you'll see in these examples. And just to explain cross multiplication, numerator 1, which will be on the left side always, will be multiplied by denominator 2, which is the denominator on the right side. And then you'll multiply the numerator 2 by denominator 1. That's cross multiplication, just to explain it out loud. Now you'll see this in the example down here. Our first one is A. You have 1/3 plus 1/2. Now if you come to the next step, as I said up here, we gotta multiply the denominators. 3 times 2 equals 6. Now we have a new denominator, which is 6. Then we're going to cross multiply right here, as you can see. I drew the arrows, and then I just did the multiplication right here. And our answers for 1 times 2 equals 2, and then 1 times 3 is 3. I put 4 right there, I'm sorry. But down here I corrected it. And as you can see, we have 2/6 and then 3/6. And if you add them together, once you have the like denominators, you just add straight across, keep the denominator the same, change the numerators. We have 5/6. So our answer is 5/6. We're going to come down to the next one and do the same thing. We're going to get the denominators the same, multiply them together, we're going to get 8. Then we cross multiply, as you can see over here. Cross multiplying, 1 times 4 equals 4, 3 times 2 equals 6. Now, our new fractions is 4/8 plus 6/8. Those two added together will equal 10/8. And this is where we get into simplifying fractions. That's not really what this is about, because our answer after we add them together is 10/8. But if you want to simplify it, just divide each of those by 2. Then you get 5/4. Or if you want to use an improper fraction, 5/4 then proper would be 1 1/4. Now, for the other half, these are subtracting. We will essentially do the same steps, except we're going to subtract. And with subtraction, you want to make sure to keep this numerator on the left side and this numerator on the right side, because with subtraction, you can't just mix and match them. So when we go to get the denominators the same, we have 4 times 3 equals 12. And then when we cross multiply, you want to make sure this one stays on the left side. So we're going to do this one first. 3 times 3 equals 9. 4 times 1 equals 4. New fractions. 9/12 minus 4/12. And then down here, I just put them in order so you can see. Subtract it straight across, and then you get 5/12. That's your answer for C. Now for part D, you have 4/3 minus 3/6. Multiply the denominators together, we're going to get 24. Cross multiply, and then we're going to get 3 times 6, 18, 3 times 4, 12. New fractions, 18/24 minus 12/24. I'm going to subtract this straight across, 6/24. Now, if you understand this, you'll notice that 6 goes into 24. So what we can do, just to skip a bunch of steps, is divide each of those by 6. And then if you do that, 6 goes into 24 4 times. So you get the 4 on the bottom. Divide 6 by 6, you get 1/4. There's your answer for that. Now, on to number 4. Number 4 is we're just multiplying fractions, okay? And I have everything that you need to know up here, but essentially what it is saying in a nutshell is when you get a whole number, to make it a fraction, you're just going to put a line underneath it and put it over 1. So with the 3 right here, you're going to put 3/1. That's it right there. It's an example. And then it's also saying that when you multiply fractions, you're going to multiply straight across. You're going to multiply the top by the top, and you're going to also multiply the bottom by the bottom. And I'll show you that over here. It'll make more sense once we get to it. So part A, you have 3 times 1 over 5. When we want to make the 3 a fraction, 3 over 1, we have 3 over 1 times 1 over 5. We're going to multiply it down here. 3 times 1 equals 3. Coming to the bottom, 1 times 5 equals 5. Our answer, 3/5. Then we're going to continue with the steps. And I'm not going to rewrite all the words out. We have 3 times 2 over 4. We're going to just bring it over here, put the 3 over 1 times 2 over 4. And then multiply straight across, you're going to get 6 over 4. And if you want to use the proper fraction, it'll be 1 1/2, because it'll be 1 2/4. And 2/4 equal half also. Now, if you want to come down to C, we have 5 times 5/8. As you can see, 5 over 1 times 5 over 8. Then you have 25 over 8. Cannot be reduced. 8 goes into 25 3 times with a remainder of 1. So we have 3 1/8. There we go for that one. And we're going to come down here to part D. Yes, part D down here. -5 times 5 over 8. Essentially, what I wrote is that when you have only one negative sign, honestly, just work the problem out the same as you always would. And then at the end, all we're going to do is put a negative sign. Remember, one negative times a positive equals a negative, but a negative times a negative equals a positive. Good rule of thumb to remember. So essentially, since it's the same as C, just with one negative, I just wrote the answer down there for you, which is -3 1/8. And I just wrote out that it's with one negative, you're just going to change the sign. That's it. So now on to 5. This is explained pretty well. And as you can see up here at the first part of it, I was explaining, and then I came down here and I was like, hey, why don't I just break up the whole square, the big square, into even pieces? And then we can reduce fractions from there. But in the first part, just so I can read it for you, this is a big square. A and B are taking up half the square. They're the same size, indicating by the tally marks, which, as you can see over here, these tally marks show that it's a square because it shows it the same length right there. Two sides are the same, the other two have to be the same. Boom. And then, so I just said A and B, they're going to equal 1/4 because they're A and B both take up half of the square. This is they both only take up half the square, and then they're evenly split up 1/4. Now down here, it gives you a better explanation. I split the triangle into 16 even pieces. We can split the whole square into 4, then make each part have 4 triangles in each, okay? So 4 times 4, we already know. We have 4 parts. 4 parts have 4 parts inside of there. 4 times 4 equals 16. That's where I got the 16 from. There's 16 triangles in the big square. And if you notice, comparing it to this, it's the same. I just didn't write the letters in because I want to show you all the 16 triangles. And you can count them if you want. Now, with each letter, we'll see how many triangles they fit. Now remember, 16 total squares, so we always want 16 on the bottom. And then for each letter, we want to know how many triangles they take up. So if you look at part A right here, come down here, part A takes up 4 triangles. So I put 4 over 16. We're not going to reduce them yet. I'm going to have B. B takes up the same amount, 4 over 16. Now I have C right here. You see C? Come over here, you see it right there. Same. It's 1 over 16. 1 6 1 space. Now D. D takes up 2, as you can see, compared to the size. D takes up 2 triangles, 2 over 16. E only takes up 1. Then you have F. F takes up 2. And then G takes up 2 triangles. So you can see I wrote out the fractions out right there. Now, down here at the bottom, I just said, hey, we can simplify each of them. And then we can see what fractions each letter take up. After simplifying. A takes up 1/4. B takes up 1/4. C takes up 1/16 because 1/16 cannot be simplified. D takes up 1/8 because we simplified it. E is 1/16. F is 1/8. And G is also 1/8. Now, on to part 6. This one's it's pretty easy. It was easy for me, per se, because I just did the multiplying fractions. And we already did that in another step, so I don't think I will explain that. But given a list of ingredients used to make 16 brownies, we'll use them to make 12. Now, if you know the fraction, we're only going to make 12, but there's a possibility of 16. If you know that fraction right there, 12 over 16, if you reduce it all the way, it'd be 3 over 4, which is the same as 75%, okay? So we'll be making 75% of these. We'll need to count all the measurements. We need to find out what percent or fraction of ingredients are needed. Remember, we only need 12 out of 16, which is 75%, or if you reduce it all the way, 3 over 4, 3/4. That's all we need. So now we're going to find out how much we need in each one, okay? We need to multiply each of the fractions, as in like when it tells you how much you need, we're going to multiply that by 3 over 4, each of them. Remember, when multiplying fractions, we multiply straight across. So there's not much work needed to be shown at all, okay? We all know how to multiply, and if you don't, we'll have a lesson on that later. But right now, I wrote down the original over here on the left side, and then the new ones with 12 ingredients over on the right side. So I hope that this is easy for you to read. I have 1/3 cup of butter. So 1/3 cup of butter times 3 over 4, you multiply that straight across, you get 3/12. Or if you reduce it all the way, multiply each of them by 3, you get 1 over 4, which now in our new one, we have 1/4 cup of butter. That's what we'll need. Now we have 3 ounces of unsweet chocolate. Put the 3 over the 1, multiply it with 3/4, multiply straight across, you got 9 over 4. Or if you want, you can simplify it to 2 1/4. So we need 2 1/4 ounces of unsweet chocolate. Now we have 3/4 cup of butter. Multiply that straight across, 9/16. Then right there, as you can see, we have 9/16 cups of sugar. That's what we'll need. Now we have 1/2 teaspoon of vanilla. This one goes, and then 3 over 2 times 3 over 4 equals 9/8, or 1 1/8. That's what that is. And then you come down here, you need 2 eggs. You get 2 over 1 times 3 over 4 equals 6 over 4, or 1 2/4. 1 2/4. You can reduce it to 1 1/2. And then as you can see above the eggs right here, I wrote 1 1/2. Or if you want to use the other fraction, use 3 over 2. But we kept it with 1 1/2 eggs. Now for the last one, it's cups of flour. We have 2 over 3 cups of flour, 2/3 cup of flour. So we multiply 2/3 by 3/4 equals 6/12. Or essentially, once you reduce it, 1/2. So we just need 1/2 cups of flour. And that is it. That's all that y'all need to see. That's everything. And just to remind you, this is questions 1 through 6 besides 2. And I hope that this was made simple for you and that you understand it. Thank you very much, and I hope that you enjoyed a lot.